Morning, everybody. Then today is our class. See it. Today we are studying about good morning, Sita. Then velocity time graph. Write down velocity time graph for a body at rest. Write down the heading velocity time graph for a body at rest. Velocity time graph for a body at rest. Can anyone tell me what will be the graph of velocity? Velocity time graph for a body at rest, what it will look like? Reply. Can anyone tell me what will be the velocity time graph for a body at rest? Anybody? Reply. What can you say about a velocity time graph? How it will look like? Body at rest. Anybody? Any idea what will be the velocity time graph for a body at rest? Means body is not moving. If body is not moving, what will be the velocity? All of you reply. If the body is not moving, what will be the velocity of the object? Reply everybody. If an object is at rest, what will be the velocity? Useless fellows. If the object is not moving, what will be velocity? 0 meter per second. If the object is not moving, velocity will be 0. Object is at rest. Look at velocity time graph for a body at rest. Object is not moving, velocity will be 0. And velocity is 0 here. If object is not moving, velocity will be 0. And velocity is 0 here. Time is passing, still velocity is 0. So velocity time graph for object at rest will be this line along x-axis. Velocity time graph for object at rest will be along x-axis. Is it clear, everybody? Is it clear? Reply. This graph is clear. Velocity time graph for a body at rest will be straight line along x-axis. Clear? Then draw the graph. Then next, velocity time graph for uniform motion. Tell me uniform motion, velocity changes or remains constant? All of you reply. In uniform motion, velocity changes or remains constant. Reply. In uniform motion, does the velocity changes or remain constant? All of you reply. In uniform motion, velocity changes or remains constant. Remain constant. So the graph will be like this. For example, 10 meter per second, each and every place the velocity will be 10 meter per second. So velocity remains constant. Pay attention. Velocity remains constant in uniform motion. Write down velocity time graph for uniform motion. Write down everybody. Then write down a straight line. In this only write down below a straight line parallel to time axis. A straight line, parallel to time axis. A straight line parallel to time axis on VT graph. A straight line parallel to time axis on VT graph, velocity time graph. A straight line parallel to time axis on VT graph shows that a straight line parallel to time axis on a VT graph shows that velocity is constant, and does not change with time. Shows that velocity is constant and does not change with time. Shows that velocity is constant and does not change with time. Then next heading up right. Have you written everyone? Have everyone written? Reply. Have you all written? Have you all written? Reply. Then write down next heading velocity time graph for uniformly accelerated motion. 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 Write down that when the velocity of a moving object changes, when the velocity of a velocity time graph for uniformly accelerated motion. Velocity time graph for uniformly accelerated motion. Then write down when the velocity of a moving object changes by an equal amount, when the velocity of a moving object changes by an equal amount, when the velocity of a moving object changes by an equal amount in equal intervals of time, when the velocity of a moving object changes by an equal amount in equal intervals of time, when the velocity of a moving object changes by an equal amount in equal intervals of time, the velocity time graph is a straight line. The velocity time graph is a straight line inclined at an angle. Velocity time graph is a straight line inclined at an angle to the time axis. Velocity time graph is a straight line inclined at an angle to time axis. Velocity time graph is a straight line inclined at an angle to time axis. The velocity may increase or decrease. The velocity may increase or decrease with time. Velocity may increase or decrease with time. And hence motion may be accelerated or retarded. The velocity may increase or decrease with time, and hence the motion may be accelerated or retarded. Motion may be accelerated or retarded. See here, this will be the graph. Motion may be accelerated or retarded. Motion may be accelerated or retarded. This is the graph here. This is time. Then, this is the graph of uniformly accelerated motion. Uniformly accelerated motion. This is the graph of uniformly deaccelerated motion or retarded motion. Uniformly retarded. Graph is clear. It is coming here. In this case, Initial velocity, look everybody on the board. In this case, for example, initial velocity was 50 meters per second and final velocity 5 meters per second. So velocity is decreasing. Starting was 50 meters per second, now it is 5 meters per second. In this case, starting was 0 and now finally it is 50 meters per second. So in this case, velocity is increasing, and that case velocity is decreasing. Graph is clear to all. Reply of is graph clear to all. Reply quickly. Everybody reply, is graph clear? Then draw the graph. If you have drawn, then write drawn or written. Everybody reply, only 3 and 4 students have replied. If you have written or drawn, write down the done, written, completed, whatever you want to write. Next heading you will write. Velocity time graph for non-uniformly accelerated motion. Velocity time graph for non-uniformly accelerated motion. Velocity time graph for non-uniformly accelerated motion. Next line you will write, when the velocity of a body increases non-uniformly, when the velocity of a body increases, when the velocity of a body increases non-uniformly, when the velocity of a body increases non-uniformly, the velocity time graph, when the velocity of a body increases non-uniformly, the velocity time graph is a curve. The velocity time graph is a curve that moves upward. When the velocity of a body increases non-uniformly, when the velocity of a body increases non-uniformly, the velocity time graph is a curve. The velocity time graph is a curve that moves upward. Velocity time graph is a curve that moves upward with a positive slope. Moves upward with a positive slope. See here, this is the graph. If the velocity of an object increases non-uniformly, velocity of the object increases non-uniformly with a positive slope. Positive slope. This is positive slope. This is positive slope. Means velocity is increasing. Velocity is or non-uniform acceleration. Increasing non-uniform acceleration. Increasing non-uniform acceleration. In this case, we are increasing non-uniform acceleration. Then next, when draw the graph first. This graph only will draw only this graph. The next, when the velocity of a body, write down next, when the velocity of a body decreases non-uniformly, when the velocity of a body decreases non-uniformly, when the velocity of a body decreases non-uniformly, the velocity time graph is a curve. The velocity time graph is a curve that moves downward when the velocity of a body decreases non-uniformly. The velocity time graph is a curve that moves downward when the velocity of a body decreases non-uniformly. The velocity time graph is a curve that moves downward. That moves downward with a negative slope. That moves downward with a negative slope. This is non-uniform. This is the graph. Non-uniform retardation. Non-uniform retardation. Write down. Then write the next heading. That is over. Now graph is over. One last note you will write. Everybody write one last note. Unit for expressing area under the curve. 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 Write down the area under the speed. The area under the speed or velocity time graph. The area under the speed or velocity time graph. Area under the speed or velocity time graph gives us the value of distance, gives us the value of distance or displacement. The area under the speed or velocity time graph gives us the value of distance or displacement respectively. Gives us the value of distance or displacement respectively, which should be expressed in meter, kilometer, which should be expressed in meter, kilometer or centimeter. Meter, kilometer or centimeter. So what does the line mean? See here, the line means look here. See here, this is the graph. Slope means acceleration. Slope means your tan theta, the angle with the slope makes with the time axis, that is slope. Slope means the angle that the curve is making with the time axis, that is called slope. Say here, in this case, graph will be given in examination and question will ask, calculate the distance. So say here, how to calculate the distance covered from the graph. See, this is the I told you area under speed time graph. Area under speed time graph or area under velocity time graph will give you the distance. See, this is the graph. Rising from here, and then there. So this is the area. This is the area that you are able to calculate. This is area under. This is the graph of speed time graph. Area under speed time graph will give you the distance. See here you can divide it into one rectangle. This particular part is a trapezium. This particular part is the trapezium. This particular part, if you divide that in a rectangle, and then again this is a triangle. So area of rectangle plus area of trapezium plus area of one triangle, you will get the total distance by adding all the areas. How to take out C? Suppose if I take it O, A, B, C, D, E, F. So area of this rectangle ABFO, length into breadth, what is the length? 15 meter, breadth is 20, 15 into 20, 300. Area of trapezium, 1 by 2, sum of parallel side, one parallel side is 15, other parallel side is 25. Height is 20 to 25, what is the height? 5. 1 by 2, 45, 100 meter. Now area of this triangle, area of triangle 1 by 2 base into height. Base is 10, height is 25. So 125. When you add 300 plus 100, 400 meter. 300 plus 100, 400 meter plus 125. That is total distance will be 525 meter. Is it clear? All of you reply it. Everybody, is it clear how I have calculated the distance? Draw the graph then. Draw the graph. If you have drawn, well and good. So, good day, everybody. Everybody, good day now.